Smith, and I'm here to continue our math lessons for HISD TV. I'm so glad you could join us, and we're going to talk through a lot of examples today that hopefully will help you get stronger in math. So let's take a quick look at our focus, and then I'll talk to you about what we're going to do together today. But first, I want you to make sure you have something to write with. A pencil is always best for math, and definitely some paper. So take a few seconds to gather those items. You will not need anything else today except for paper and a pencil and just a great attitude. So go ahead and grab those. Great. And again, I'm Miss Smith from Sinclair Elementary, and I'm really happy to be here with you today. So let's take a look at our focus today. Our focus is that we are going to add and subtract decimals. So we're moving on from where we've been in the last few weeks when we've been talking about place value and where numbers belong and where they exist and how we can start moving them around. So I always like to start out the lesson with a little bit of review. So let's go back to the most important thing in 5th grade, and that is our place value. So let's take a look. Place value is where numbers live. So let's take a look at the place value that we visited in 5th grade. So I'm gonna start by putting just a ones place. The decimal will signify our divide between whole and decimals. Okay, this should look familiar to you. Usually you will see a place value chart like this with a decimal. And some of my students have been asking me, Miss Smith, why do we talk about place value so much? And the answer to that is that because it's important, right? It's something that's gonna take us through the entire school year. You have to know the values of where numbers are. If we didn't know the values, we wouldn't be able to compare any real life scenarios. And we're gonna do some real life scenarios today in our example. So come on with me. All right, so this would be the ones place. Ones, so again, this side's whole numbers. We said this was tenths. Second one was hundredths and thousands. I'm gonna put a TH for thousands, okay? So a number like 3.265 goes all the way to the hundredth place. But hopefully you guys already know and remember that, because today we're gonna expand on that, okay? Today we're gonna add and subtract whole numbers and decimals together. So the most important thing about today is keeping up with the decimal place value. You have to know where to put your numbers. We're gonna be lining them up. And when I say line them up, I mean put them in the correct order. The decimal is always gonna be your main guiding factor to help you figure it out. So I'm gonna start easy by just giving you a few decimal numbers to add together. We'll move into problem solving as we move on throughout this lesson, okay? So let's learn. Okay, so we reviewed place value. We talked about what we're gonna focus on today. And now we're gonna kind of turn our brains on extra so that we can follow along how we're gonna apply our knowledge of place value to adding and subtracting decimals. Then at the end of class, we're gonna do 2 examples together. And by then you're gonna feel really confident in adding and subtracting. Okay, so again, I'm just making these numbers up, so you write them down with me, okay? Come on. Let's just make some up. Say we want to add 2 numbers together. We want to add, so I'm gonna put EX1. And when I teach, I always give plenty of examples so that you guys can learn to follow along with me. So EX1 actually means example 1. So as I keep going, we'll move on so you know how to keep track in your notes. So EX means example. It's just a short way to write example. So example 1 is just adding 2 different decimals together, which include whole numbers. So let's add, the 2 numbers I have are 25 and 3/10 and 16 and 85 hundredths. What if someone just said, can you add those 2 measurements? Say for example, these are inches. The length of something, and maybe I had 2 pieces of wood and I could see how far I could stretch it, but how do I add that? Do I just add any number to each other that I want? Well, the answer is obviously not, because I need to keep track of my place value. So I'm going to stack these numbers on top of one another. And when I say stack, I mean line up the decimals, and then I can add them. So let's do it together. So you write down this in your notes. 25.3. That's where this number comes from. Now watch carefully. As I take this second number, I'm going to make sure that the decimal stays right underneath the other decimal so I can add them together. So I know I have a 16, a 1 in the tens place, and a 6 in the ones place, and then I have an 8 in the tenths place, but be careful, I also have a 5. I know I'm going to add them. So let's take a look at that for a moment. Sometimes students say, Ms. Smith, that looks funny. Like one of the numbers is not the same size as the other. Something must be wrong. I can't add it like that. That's actually not true. As long as your decimal is lined up, you can supplement, which means fill up, the other part of the number with zeros, because zeros have no value and they don't make the number bigger or smaller, and then keep our problem nice and clean. So just like we did with comparing and ordering decimals, we're just gonna add that 0 to help keep this clean. So we're gonna add a 0 here. Adding this 0 means I added nothing to the problem. So think about that. If I added nothing, can I add a 0? The answer is yes. So now I'm gonna take a different color and I'm gonna, from right to left, I'm gonna add up the numbers, just like I know how. So here's my operation, the plus sign. And the way you knew to add these is I just told you to. I just made up this problem. We haven't gotten into word problems yet. Okay, so let's add them up. 0 plus 5 is 5. Hopefully you got that. 3 plus 8 is 11. Notice I'm simply bringing down the decimal because I line them up. So of course my answer is going to have the lined up decimal, and then I'm going to add these. Don't forget that I carried that 1. So I always tell students, add this 1 first so you don't forget it. 1 plus 5 is 6, plus another 6 makes 12. So I'm going to put the 2 here, carry the 1. Don't forget to carry your numbers. 1 plus 2 is 3, plus another is 42. So your answer is 42 and 15/100. So notice we line up our decimals and our answer's decimal is in the same place. So if we had been measuring 2 pieces of wood, we could say that their total length was 42 and 15/100. So that was just a simple example of lining up the decimals. Let me go ahead and move this so I don't tear it off the wall. Okay, so that was an example of the lining up of the decimals. Okay, so the next thing we want to talk about is how can, let's do one more example. I had one more plan for you. I don't really like doing these videos. There's times I forget something, and that would happen in a real class too, right? Let's do one more where we line up our decimals. Okay, before we get to the strip diagram. Okay, so let's say it's raining a lot in Houston lately. Didn't we just had this tropical storm happen, Beta, tropical depression? Let's talk about rainfall. That's something that everyone can relate to right now. Rainfall, right? It's raining so much. So since it's been raining day after day after day, let's think about taking one day that it rained and another day that it rained, and tell me the like it rained a lot this day and it also rained a lot this day, but it wasn't the same exact rainfall. We could calculate the difference between rainfall days. So let's pick a day. So like today's my Tuesday. I don't know what day it is for you, but it might be a different day because I recorded this. But let's say yesterday it rained, it was Monday, and today is Tuesday. So let's say that yesterday it rained some inches, and they usually measure rain in inches. So let's say on Monday it rained 3.25 inches. I can write inches over here so we know we're talking about inches. And Tuesday it rained 2.81 inches. And what if someone said, well, it's been raining so much, but like what day had more rain? Well, we could answer that question, right? Because we can see that it rained more on Monday just by looking at our greatest place value. But how do we figure out how much more it rained on Monday? So think about that. How much more did it rain on Monday? We know it rained both days, but how much more? So let's think. Yeah, so we would subtract, right, to find the difference. So let's do that. So we're going to take the larger number, and from that number we would subtract the smaller number, and that tells us the difference in the rainfall between Monday and Tuesday. So come on with me. So it's already lined up for us here. I'm going to put a minus here. When I say lined up, those decimal numbers must be lined up. You cannot move them around and have them in different places. So make sure when you're adding and subtracting, whole numbers and decimals must line up. So 3.25. So let's start on the right side. 5 minus 1 is 4. 2 minus 8. Well, we can't do that, so we have to borrow and make this a 12. And we borrowed from one neighbor over, one place value over. 12 minus 8 also gives us 4. Of course, the decimal comes down. 2 minus 2 is 0. So the difference in rainfall between those 2 days is 0.44 inches, so less than half an inch. Okay? What about something like this? What if you had money? We all like some money every now and then. What if I had $20? I'm gonna use my green marker because we're talking about money, and paper money is green, right? So what if I have $20? Yippee! I have $20 and I needed to buy, let's buy something. Say I bought 2 Gatorades, like I was exercising a lot that day, right? Because we should all be exercising. And I bought 2 Gatorades, and so that cost me like $3.28, including tax. So it was $3.28 for my Gatorades. I got 2 because I was exercising a lot. So how much money do I have left after I drank my Gatorades? So let's think about that. And I went ahead and put the 2 decimals here. Some people would say, well, Miss Smith, you don't have 2 that. No, this is 20. Look, I just wrote 20. But in decimal form, I have to say that $20, which is a whole number, minus $3.28. So look carefully at what I did. Look where I put the 20. Right next to this whole number, because I'm not going to move it all the way over here because then it would be in the wrong place. I have to add 0.00. Remember I said you could add nothing. I'm adding nothing. That's still $20. I added my place value so that when I go to subtract, I don't subtract from the wrong place, the wrong location. So keep that in mind. Whole numbers, decimals have to be lined up in the same place. So here we go. $20 minus $3.28. So I can't do 0 minus 8, so I'm going to borrow from here, which means I have to borrow from this 0 and this 0 all the way over to the 2. So I have to go all the way to the last place. Now I can do it. 10 minus 8, 2. 9 minus 2, 7. 9 minus 3, 6, and 1. So if I had $20 and I spent $3.28, I would have $16.72 left. And the last thing you think about before the end of the problem is, does that seem reasonable? Reasonable means, does it even make sense? Like if I have $20 and now I have about $16 left after I bought a Gatorade, yeah, that makes sense, right? But what if I had $20 and I knew I only bought 2 Gatorades and I had $1 something left? Then I would have known I did something wrong, because 2 Gatorades aren't going to cost $20. So you have to start thinking about, does this make sense? Like, is it reasonable that I would get this answer? And so in this case, yes. All right, so we're going to practice 2 together now from using a strip diagram. And I'm about to show you what that is. Hopefully you've seen one before. All right, make sure you have a clean sheet of paper to work on. So, a strip diagram, I have a little note for you. Look, I put it in big bright orange so that you would read it with me. So behind me is a strip diagram, which is basically a giant box, but it helps you. But how does it help you? So it's gonna help us with adding and subtracting. So let's think about that. The strip diagram helps us represent relationships. So as you know, in math, they often give us like a story, a problem, a scenario. And like a lot of people get lost and say, I know how to read it and I understand that this is about watermelons or something, but I just don't even know what to do. So strip diagrams are helping us understand the relationship of what's happening with the information they give us. And then guess what it does? It helps you. So we know which math operations to use. And these are math operations: plus, minus, multiply, and divide. So most people know what they are. The hardest part sometimes with math is knowing which one to use and when. So let's think of the strip diagram as a tool to help us represent relationships that help us understand what to do. So think about that. I'm gonna put this off to the side so you can be new best friends with that strip diagram. Okay, I like to give you guys tips. Okay, so I'm gonna give you our first example. There's a total of 2, so both of these you will follow along with me. Okay, oopsie, it's kind of crooked. You can read that, we got this. And I found my trusty pointer. Okay, let's show our learning. I'm gonna straighten this up for you because it's kind of bothering me. Okay, so the first thing we're gonna do, before you do anything in a math problem, read the whole thing. That way you can kind of just think about what are they actually showing me, right? So I'm gonna put this down so we can focus on the problem. Okay, so sometimes I like to clean off my workspace like that so that I can focus my energy just on that problem, okay? So that's what we've done here. And I have a little math talk. Okay, so let's read this together very slowly. And as we read the problem together, I'm gonna underline some important parts. And most importantly, I'm gonna underline the question. Okay, the regular price of a backpack is $18.49. That's the regular price. Alyssa paid 50 cents less than the regular price. So she's paying less for the backpack. Think about that. So we're talking about a backpack. She also paid $3.68 for a binder. What is the total amount Alyssa paid for these 2 items? So I always tell my math students, the very first thing you do after you read the problem is highlight the question. And since I don't have a giant highlighter, I'm just gonna underline it. Highlight only the question. Starts here. What was the total amount Alyssa paid for these 2 items? I love underlining the question because it's kind of the most important part, right? So there's so much happening, but at the end, they just want to know the question. So let's go back to the question. What was the total amount Alyssa paid for these 2 items? Total amount. So it's obviously we're adding them, right? We're adding these 2 items together. So there's 2 things she bought, a backpack and a binder. But something happened with the backpack. So what do you think about that? Okay, so we want to know drawing another strip diagram here, and we're going to use that one for the other problem. So the total amount she paid, we don't know. This box is going to be used to represent the total amount that she paid, okay? And we know for a fact that she bought how many things? 2. We didn't say anything about change. We just know that there's 2 items. So I'm gonna break this in half. And this is gonna be, there's two things she bought and we don't know how much total. So she bought a backpack and a binder. Okay, so she bought a backpack and a binder. So far so good, right? So this helps us say two things bought, one total. We don't know the total, but we know how much she paid for the stuff. So let's look at that. She paid $18.49 for the backpack. And the reason I know that, it's from here. And then she paid $3.68 for the binder. True. But something else happened to her backpack, didn't it? She got it on sale. So I'm gonna leave the binder alone because the binder was $3.68, but she paid 50 cents less than the regular price. And the regular price was that. So if she paid 50 cents less, I need to subtract that discount. So I'm gonna say this backpack minus 50 cents. She got it on sale. So she gets her 50 cents back. So that's why I'm taking 50 cents off the cost of her backpack. Think about that. She paid 50 cents less. So now after I subtract that, I'll know the real cost that she paid for the backpack, and then I can add the binder to it. So here we go. So remember, I'm subtracting because she's getting her money back. 9 minus 0, 9. 4 minus 5, I can't do that. I have to make this a 14, borrow from here. Then 14 minus 5 gives me another 9. 7 minus 0 is 7, and 1. So she actually only paid $17.99 for the backpack. And then what else did she buy? The binder. So I'm gonna add the binder because we're trying to figure out, look, go back to your strip diagram. The total amount, here's that word, total amount she paid for these two items, which is my blank here. So now I'm adding, because I'm adding up how much she bought total. 9 plus 8, 17. Remember, start with the 1. 1 plus 9 is 10, plus a 6 is 16. Carry the 1. 1 plus 7 is 8, plus 3 gives us 11. Carry the last 1. And I know that she spent $21.67 on both of those items together. And if you look at the strip diagram in your head, it helps you make sense of what's happening. And that's what it helps you with that operation. So going back to this, the strip diagram will help us with the relationship. And in this case, the relationship here is that these two items need to be added together to give us the total cost. That's what they're asking us for. But in the process of adding those two items, we have to stop for a brief pause and get the correct price for the backpack because it was on sale, right? You're doing awesome. Okay, one more example, hang in there. So we're gonna put the backpack example away, and we're gonna use this strip diagram for our next problem. So hopefully you still have your notes out. And this one's a little bit longer, but notice I keep taking these down so you can focus. All right. Here's our newest one, and I've prepared it for you. So go ahead and look at it for a second while I clean this up. You're doing awesome. Okay, just hang in there with me. Just about 5 or 6 more minutes, and we're gonna get through this lesson. Okay, last example. So Dylan, we have a new friend. Last time it was Alyssa, now it's Dylan. Dylan has a total of 2 $20 bills, 3 nickels, 4 pennies. So this is what he has. He went to the store and bought 2 packs of baseball cards that cost $3.85 each. 2 packs. Interesting. Third, $3.85 each, and a toy baseball bat that cost $5.50, including tax. Here goes my highlighter. In dollars, So obviously we're counting money. How much money does Dylan have left after his purchase? How much money does Dylan have left after his purchase? So he's got some money and he did something with it, and then how much is left, right? So behind me, this strip diagram is going to help us figure that out. We want to know how much money he has left. So the total amount is going to be how much money he has, right? Well, I don't know how much money he has. Do you? I knew you knew that. Add up the money, Miss Smith. Let's add it up. Two $20 bills. $20 bills. So count by 20s, right? 20, 40. So he's got $40 here. Let's add it up. I'm going to put 40 because that's two 20s. 3 nickels. So nickels are 5 cents. 5, 10, 15. So 15 cents. 0.15. And 4 pennies, which is 4 cents. Now remember, pennies go out to the hundredths place. Okay? So I need to add that up. I didn't line them up, so I need to add that up, right? I'm going to add them up. Let's see. I'll add them up right here. This is his money. $40. Those are his two 20s. 15 cents. And 4 pennies, which is 4 cents. So now I'm going to add all that up together. Notice, lined up my decimals. 0 plus 5 is 5, plus another 4 is 9. 0 plus 1 is 1, plus another 0 still stays 1. All zeros and 40. So I know that all the things that his total that he has is $40.19. And that $40.19 represents the total of something that happened. So back to our strip diagram. Let's think about what we have. So he got 2 packs of baseball cards, a baseball bat, and then he got some money back, right? So let's divide up our strip diagram. I know the total is what he has. So he bought a baseball, we call this, I'll put BB cards. And the second pack, so let's put baseball cards 1, baseball cards 2. Remember, he bought 2 packs of baseball cards. Then he had a baseball bat, a toy bat, and then he had some money left over. I'm gonna put an exclamation point. So he bought 2 packs of baseball cards, a toy bat, and some money left over. And so this change right here is our big question mark. We know the total has to be this, and if we plug these in, we should be able to figure this one out. Again, the strip diagram really helps. So let's put in the baseball cards. This was $3.85, this was $3.85, and our problem told us that his baseball bat was $5.50. This is my dollar sign, and don't know that one. So let's add up what we know, then subtract it from how much money he had, and then we know how much money he left over. It's kind of like the Gatorade example we had earlier, right? I know I had some money. We know how much money he has. He knows he spent some, and he knows he's gonna get some back. So that's all we have left, is just to do the math. You're doing awesome. So let's add up how much he spent, and I'll keep using the pink one so that you know what I'm adding. So I'm gonna add up what he bought. $3.85, another $3.85. Okay, let's add these first. 5 and 5 is 10, carry the 1. 1 and 8 is 9, plus 8 is 17. Bring down your decimal, carry the 1. 1 plus 3 is 4. 4 plus 3 is 7. 770, that's just the cards. Now I have to add the toy bat, which was $5.50. 7 plus 5 is 12. Carry the 1. 1 plus 7 is 8, plus 5 is 13. So 1320 is how much money he spent. So we know how much he spent, we know how much he started with, and that can give us the change. So that's all there's left. And I'm gonna come over here for the final calculation. I'm gonna write final, because this will help us get there. So he had $40.19 minus the total he spent, $13.20. That's all we have left in this one section, and then it'll give us the change. 9 minus 0, 9. 1 minus 2, impossible. Let's carry it. Borrow from this one. 11 minus 2, 9. 9 minus 3, 6. And 3 minus 2 gives us $26.99. So $26, I'm gonna change for a final. $26.99 was his change that he got after he spent his money. And what should he do with that change? You said it, save it. Don't spend all your money. Can't wait till next time, guys. Great job.